The Space Launch System, or SLS, is a titan of a rocket. NASA built it for a singular grand purpose. It will carry humans back to the moon. It is the cornerstone of the Artemis program. This rocket is a new machine. It is incredibly complex. It requires extensive testing before its first flight. Sometimes tests don't go according to plan. A rollback is a perfect example. It's when the massive rocket is moved off the pad. It slowly travels back to the vehicle assembly building for safety or repair. The move is deliberate. Engineers chose it. The recent rollback grabbed public attention. The towering vehicle had been poised for a critical test. During that test, engineers detected problems. They decided to move the rocket back to the VAB. The journey is slow and methodical, taking many hours. It signals a pause in pre-flight prep. It means more work, more analysis, more time. Rolling back is not failure. It's cautious, thorough testing. The Space Launch System is the most powerful rocket ever built by NASA. Its job is to launch the Orion spacecraft. Orion will carry astronauts on missions to deep space. The first destination is the Moon. Later, the goal is Mars. The SLS rocket stands taller than the Statue of Liberty. It generates more thrust than the Saturn V that took Apollo astronauts to the Moon. This immense power is needed to push heavy payloads out of Earth's strong gravitational pull. The rocket is made of a massive core stage, 2 solid rocket boosters, and an upper stage. Each component is a marvel of engineering, and they must all work together perfectly. A rollback is a standard procedure, though one that teams hope to avoid. It is the process of moving the fully assembled rocket stack. The rocket sits on a mobile platform called the Crawler Transporter. This colossal vehicle, moving at about 1 mile per hour, carries the rocket between the vehicle assembly building and the launch pad. The VAB is a gigantic hangar. It protects the rocket from weather and provides the infrastructure for assembly and detailed repairs. A rollback is initiated for a few main reasons. It could be due to an approaching hurricane. It could be due to a technical problem that cannot be fixed at the pad. Or, it could be to perform planned upgrades. The wet dress rehearsal is the final major test before launch. It is a comprehensive check of both the rocket and the ground systems. The team practices the entire launch day timeline. This includes filling the core stage and upper stage with hundreds of thousands of gallons of cryogenic propellants. They proceed through the countdown, stopping just before the engines would ignite. This test is crucial. It verifies that the rocket's tanks can be loaded and drained safely. It confirms that all the valves and pressurization systems work under extreme conditions. It is the closest thing to a launch without actually leaving the ground. The recent rollback was triggered by data collected during this critical test. Engineers found a persistent hydrogen leak at a tower-to-core connection. Hydrogen, being the smallest molecule, is notoriously difficult to contain. While small leaks can sometimes be managed, this one exceeded safety limits. Additionally, there were smaller issues with software and sensor readings. Fixing cryogenic plumbing is safer and more effective inside the VAB. The team prudently rolled back for a thorough repair and re-evaluation. One primary problem was a leak in a quick disconnect fitting. This fitting is part of the tail service mast umbilical. It feeds super-chilled liquid hydrogen into the core stage. Sensors saw hydrogen above allowable limits. The seal was not perfectly tight. Liquid hydrogen is highly flammable. The launch cannot proceed with that risk. Fixing it on the pad would be difficult and dangerous. The rollback immediately impacted the mission schedule. Each day off the pad is a day the rocket can't launch. The process takes weeks. Rolling back, making repairs, rolling out again. Back in the VAB, engineers methodically troubleshoot, replace the faulty seals, verify the fix on smaller scale tests. That sequence pushes the earliest launch date farther out. Delays also drive up program costs. The SLS program uses a massive budget. Teams involved, engineers, technicians, support staff. Every extra week increases operational expenses. Costs include salaries, facility maintenance, and resource consumption. The immediate solution involves a hands-on repair inside the VAB. Technicians will access the quick disconnect fitting. They will carefully remove the existing seals and inspect for damage or contamination. New certified seals will be installed. The team will perform ambient tests, then cryogenic tests on that connection, ensuring the new seal holds under extreme conditions. NASA will enhance testing procedures. More verification before the rocket leaves the assembly building. More rigorous checks on individual components, especially seals, prior to integration. Refining software and sensor monitoring to filter false readings. Lessons update checklists and procedures, making the process more robust and less halt-prone. Longer term, redesigns may be needed for persistent offenders. New materials or mechanisms could be selected. That requires engineering, manufacturing, and qualification tests. The next major step is a clean, wet dress rehearsal. After repairs, SLS rolls back to Launch Pad 39B. The team will run the full countdown again, closely monitoring the repaired connection and all systems. Success means loading propellants and reaching final seconds without violations. A clean test sets a firm date for Artemis III and clears the gateway to flight. In conclusion, the rollback is a visible reminder of the immense challenges of space exploration. Building and testing a new super heavy-lift rocket is incredibly difficult. The problems encountered, leaking valves, sensor issues, ground support glitches, are not unexpected in a program of this complexity. They are discoveries from a deliberate, methodical test campaign. Rollbacks cause delays, but they are critical to the process. They let engineers fix problems safely and effectively, ensuring the vehicle is safe and reliable before it ever leaves Earth. Fixes range from simple seals to refining complex testing software. Each correction is based on real-world data. These actions address the root causes of delays. Implement the fixes. Complete a clean wet dress rehearsal and clear the final hurdles to launch Artemis I. The safety of future crews depends on lessons learned today. The success of SLS is fundamental to Artemis. It can send Orion, its crew, and large cargo to the moon in one launch. Those historic milestones depend on SLS flying regularly. Delays are frustrating, but they reflect test as you fly. Each rollback and repair brings us closer and ensures we reach for the stars safely.